Hi, Geography 114. This lecture is going to be about climate change and the Bahamas. Now, I told you guys before that climate change is the area of research that I'm interested in. So I'll tell you a little bit about some of the research that I've been done and also give you an overview of how climate change will affect the Bahamas. All right, so let's get started. All right, so let's talk about climate and climate change. As you know, climates are the average weather conditions of a place for a period of at least 30 years. Anything less than 30 years and you are talking about the weather. A good way to remember the difference between climate and weather is that climate is what you expect because it is the average weather conditions, but weather is what you get. All right, so you may expect a place to be very warm. However, the weather on a certain day may be cold. All right, so climate are average weather conditions over a very long period of time, at least 30 years. Now, you should have an inherent idea that there are differences in climate. So the summertime climate is different than a wintertime climate. The climate in somewhere like the Sahara Desert is much different than the climate in somewhere like Canada. The way that we measure the climate is we use scientific measures. So we do statistics on average temperature, rainfall, things that we've been looking at in this class already. So over here on the right, this is a climograph, and it should be familiar to you because we looked at climographs in our lecture on how we classify different types of climate. All right, so along the bottom, we have the months. Up the left side, we have the temperature, and up the right side, we have precipitation. All right, and the bars show you precipitation, and the different colored lines show you different temperature profiles. All right, so that's a very complex climograph. Remember that in this class, we're doing more simple climographs. All right, so what is climate change? Climate change are statistically significant and measurable changes to the climate. All right, so it's looking at how the climate of a place changes over time. It's not looking at the weather from day to day. Now, the climate of different places has changed over time in the past, but what is different about now is that the climate is changing at a very rapid rate. It's changing faster than it has ever changed before. And so the big question that scientists are looking at are what are the implications of these rapid changes to the climate, and also what is causing these changes to the climate, causing these changes to happen so rapidly. So in order to answer this question, the IPCC, which stands for the Intergovernmental Panel on Climate Change, was formed in 1988. And it was a collaboration between two agencies, the WMO, the World Meteorological Organization, and UNEP, the United Nations Environmental Program. And the purpose of the IPCC is to provide governments with clear scientific views on climate change and also about the impacts of climate change. So it does this through thousands of volunteers, scientists all over the world come together, and they review all of the scientific literature that has been produced about climate change. And what they do is they provide summaries of all of this literature to give a state of knowledge of what we know about climate change. The IPCC reports are considered to be the most comprehensive and up-to-date assessment of climate change. And so these reports are called assessment reports, and there have been 5 assessment reports. The first one was in 1990, and the last one came out in 2013 and 2014. All right, so here's a picture of some of the many different volunteer scientists that come together to review all of the scientific literature and to come up with the assessment reports. And I was actually one of the volunteer scientists, and this is in 2013 in Slovenia, which is a country in Europe. So if you look at this long enough, you can spot me. I'm down there in the front to the left, and I have on the aqua shirt. And so it was really great to be a part of the IPCC. I learned a lot about climate change. I was able to interact with scientists from all over the world. And so now let's go into some of the messages that have come out of that latest IPCC report that came out in 2014. All right, so the latest report that came out, key messages from IPCC WG5, and WG5 stands for Working Group 5. So the first key message that came out of this report is that the human influence on the climate is clear, and we are already seeing changes to the climate. All right, so climate change is not something that is just going to happen later on down the line. We are seeing climate change now. And changes to the climate cannot just be changed by natural factors. We are seeing that human activity is affecting the climate. All right, so this graphic shows some of the changes that we have seen in the global climate. And so the arrow going up means that we have seen increases in those indicators. So we have seen increases in sea level, in water vapor contents within the atmosphere. We have seen increases in the temperature of both the air and the ocean. And we have seen increases in ocean acidity. So the ocean is becoming more acidic. We have also seen decreases in some parts of the climate. We have seen decreases in the amount of snow cover, decreases in permafrost, and remember that permafrost is land that is permanently frozen. We've seen decreases in the amount and coverage of glaciers and ice sheets, and we've seen decreases in Arctic sea ice. So that is ice that is found in the sea up in the Arctic region. All right, and so this graph shows us the average global surface temperature. So this is the average temperature of Earth on the whole. And the global average temperature has risen about 1.6 degrees Fahrenheit over the past century. And so you can see those last three bars on the right. Each of the last 3 decades, so the 1980s, 90s, and 2000s, has been warmer than the previous decades. All right, so overall, we're seeing that this temperature from the 1880s, the average global temperature, has been increasing over time. And so you can see how much higher the average global temperature is in the 2000s than it was back in the 1880s. Now, this increase in temperatures, what scientists have found is that it is related to the increase in concentrations of carbon dioxide in the atmosphere. All right, so this graph shows us the average annual temperature, and that is in the orange line, and you can see that as it goes up and down, but overall there's a definite upward trend. And then the yellow line shows us concentrations of carbon dioxide within the atmosphere. All right, so you can see that from 1880, it's gone down from about 300 parts per million. And by 2013, it's up at almost 400 parts per million. All right, so the increase in carbon dioxide has been associated with the increase in the global average temperature. Now, this should make sense to you because, as you know, carbon dioxide is a greenhouse gas, and our greenhouse gases trap heat within the atmosphere. Now, what is significant about this graph is that humans have been contributing to this increase in carbon dioxide within the atmosphere. So since the industrial age in the 1800s, humans have been emitting carbon dioxide through burning fossil fuels, and this has been affecting our climate by making temperatures go up. All right, now this increase in carbon dioxide is quite alarming. So this graph shows us the percentage of carbon dioxide within the atmosphere from 800,000 years ago up to present times. And you can see that the range of carbon dioxide has gone from about 175 and it's gone up to about 300 parts per million and goes up and down until you get to this part that is in greater detail from 1958 to 2014. You can see that carbon dioxide is just going up at a rapid rate. All right, and we're up to 400 parts per million, and this is the highest concentration of carbon dioxide that we have seen in the past 800,000 years. All right, 400 parts per million was a concentration of carbon dioxide that scientists were hoping would not be reached, but it was actually hit in May of 2014, and since then it has been hit a number of times. All right, so very alarming increases in carbon dioxide within the atmosphere. We have also been seeing rising temperatures of the ocean. So this graph on the left shows us the temperature, the global sea surface temperature, all right? And so you can see that there has been an increase in sea surface temperatures from 1880 up until the early 2000s. All right, and air and ocean temperatures have been rising faster in the Arctic region than it has been rising anywhere else. And so on the right here, you can see this is the extent of Arctic ice. So that is ice that is found within the Arctic region. And the blue, the lightest blue, shows you the extent of Arctic ice in 1970. And then a little bit darker, 1980, darker, 1990. All right, up until 2007, you can see that the area covered by ice in 2007 is much less than was in 1970. So we're seeing that Arctic ice is shrinking. And by 2100, you can see that pink area, that is how big we expect the area of Arctic ice to cover. So compare 1970 to 2100. All right, so as the sea temperatures get hotter, the Arctic ice decreases. So we're seeing much less Arctic ice overall. Now, these warming temperatures of the sea have led to the decrease in Arctic ice, but it has also led to the melting of the ice sheet in Greenland. All right, so these pictures show you portions of the ice sheet that covers the continent of Greenland that have been coming off of that ice sheet and falling into the water. So on the right, you can see in the white where the extent that the Arctic ice sheet covered in 1992, and you can compare this to 2002. All right, so this is very, very rapid shrinking of that ice sheet over time. This is happening faster than it has ever happened before. All right, so we have record levels of ice that is melting and falling off and into the ocean. And what this causes is it causes the sea levels to rise. All right, if the entire Greenland ice sheet melts, then you can expect sea levels around the world to rise by up to 20 feet. Now, that is quite a lot of sea level rise. So we hope that the whole Greenland ice sheet does not melt. All right, the second key message that we have from that report from the IPCC is that the more that we disrupt our climate, the more risks that we have, the more severe those risks will be, and that there will be irreversible impacts. So you won't be able to fix the climate, basically. Basically, this is saying that the longer that we continue to emit fossil fuels, in particular carbon dioxide, the more severe that the impacts will be. Now, already some impacts that we are seeing and some impacts that we will continue to see are irreversible. So carbon dioxide remains in the atmosphere from 50 to 200 years. So even if we completely stop emitting carbon dioxide today, the carbon dioxide that is already in the atmosphere will continue to have impacts for up to 200 years. Okay, and this is similar to what we talked about with the CFCs in the ozone layer. All right, once you stop emitting a pollutant, it doesn't just go away. All right, it stays within the atmosphere. Now, this graph shows us what would happen to global temperatures based on two scenarios. So on the left, the black line is what has happened to the temperature based on carbon dioxide that we have already emitted. Over to the right, we see two different lines. The red line, which is going up, and then the purple line, which is not going up as rapidly. So the purple is increases in temperature if we substantially decrease the amount of carbon dioxide that we are emitting. All right, so if we if we emit less carbon dioxide, then our global temperatures will not rise as quickly. However, the red line shows what will happen if we continue to emit carbon dioxide at the rate that we are emitting it now. And you can see that the temperatures are expected to rise significantly. All right, so the amount of carbon dioxide that we emit in the future affects how hot it will be in the future. All right, very basic. All right, the third key message that we have from that IPCC last report is that we can limit climate change and we can build a more prosperous and sustainable future. So it is not inevitable that sea levels have to rise by 20 feet and that it has to become so unbearably hot. We can do some things. We can mitigate, and what mitigate means is it reduces emissions of greenhouse gases. And we can do this through using cleaner forms of energy, such as solar and such as winds, all right? And this reduces levels of deforestation, so we won't cut down as many of the vegetation, and we know that vegetation is important in capturing carbon dioxide from the atmosphere. All right, so we can do that. We can reduce our use of fossil fuels and our emission of carbon dioxide. Another thing that we can do is we can adapt. So we can anticipate what changes will be to the environment, and we can take action to reduce any damaging impacts. So this picture here shows you a lot of heavy development right along the ocean and right along the water. So knowing that sea levels are going to increase in the future, it probably does not make sense to build right along the water, because that water is eventually going to raise and it's going to destroy whatever infrastructure that you have within its path. All right, so we can adapt. We can say we're expecting the water to rise, and so we're not going to build right on the coast. All right, so mitigation and adaptation. All right, now let's look at what are some projections of what the climate will look like in the future and what the environment will look like in the future. And again, this is based on the latest report from the IPCC. And we're going to look at what are the implications of this for the Bahamas. Now, the Bahamas is one of the top 10 nations in the world that is most vulnerable to the impacts of climate change. All right, so we are highly vulnerable to climate change. And this is due to our environmental, our demographic, and our economic characteristics. All right, so we, as you know, we are a nation of small islands, and we don't really have much elevation. All right, all of our islands are pretty flat. In addition to this, we build a lot of important things right along the coastline where it is vulnerable to sea level rise. And also, in addition to that, we are very dependent on our tourism product. And our tourism product is focused on our beaches and our water. So if we have changes to our natural environment, then we're going to have changes in basically every aspect of Bahamian life. So let's look at some of these projections. Okay, so the first projection that we will look at is changes to temperature. Now, the IPCC predicts that the temperature will continue to rise, and this is temperatures of both the atmosphere and the ocean. All right, so the IPCC projects that the changes in global temperatures are likely to exceed 1.5 degrees Celsius by 2100. All right, and this will also be accompanied by more intense, frequent, and longer lasting heat waves. And this causes a lot of impacts for life here in the Bahamas. All right, firstly, heat stress. So it already gets quite hot here, especially in the summers, as you may know. Imagine it getting hotter than it is now in the summers. This will cause heat stress for both humans, but it also will cause heat stress for our wildlife. So in particular, if you think about corals, corals can only stand temperatures of a certain degree. And once it gets too hot, then those corals become bleached. So down at the bottom, we have an example of a healthy and vibrantly colored coral. And on the right, we have bleached coral. And that's what happens when it gets too hot. All right, so if you have coral bleaching, then the coral dies. You will not have the fish and the biodiversity, so we'll have a loss of biodiversity, and we'll also have a loss of protection from waves from the ocean. All right, so corals act as a breaker for waves. If you lose those corals, then you will have higher waves that come onto shore, and that is going to affect any coastal development that you have. The next projection that we'll look at is changes in precipitation patterns. So for the Caribbean region, the IPCC has projected that there is very likely going to be a decrease of about 12%, and there is very likely going to be an increase in intensity of precipitation events and longer periods of time between events. So what this means is that overall, we will get less rain. When we do get rain, it's going to come very intensely. So we're going to have those very intense rain events. And you know what happens in Nassau and in a lot of these family islands when we have that intense rainfall. It floods. All right, so these are some pictures from flooding right here in Nassau. And you know that our roads are not really built to handle intense rainfall. And this is what happens. So it affects the roads and also people's houses. Decreased precipitation overall will also lead to a decreased availability of fresh water. All right, fresh water is what we use for drinking, and so we will have a shortage of water. All right, the next thing that we're going to look at is sea level rise. Now, sea level rise is perhaps the most important for the Bahamas, and this is because we are small, low-lying islands, and the majority of our land is at sea level. So the IPCC projects that there is very likely to be between 1.5 to 3 feet of sea level rise by 2100. And this is actually a very conservative estimate. Remember that if we have melting of that Greenland ice sheet, we could expect sea level rises of up to 20 feet. Now, if we get significant sea level rise, even which is projected, this could be catastrophic for us. Most of our infrastructure, such as our airports, our marine transportation ports, our energy facilities are right near the coast. Okay, a lot of people live near to the coast. And this will lead to coastal flooding and erosion and the loss of very essential infrastructure. The rising of salt water can also get into our freshwater aquifers, and our aquifers is where we get some of the water that we drink. And if we have a lot of loss of land, so a loss of our low-lying areas, it could very likely lead to the need for people to migrate or for people to move away from certain areas. And I'll let you think about which areas people would need to move away from. All right, so this graph shows us the percentage of land area affected given different rises in sea level. And on the left, you have the percentage impact by area, and along the bottom, you see different countries. Now, which country is that on the left that has the most amount of area impacted by sea level rise? That is the Bahamas. All right, so this is for different countries within the Caribbean, and the Bahamas is by far the most vulnerable to climate change. All right, you can see that with just 1 meter of sea level rise, over 10% of our land area is expected to be impacted. If you raise this up to 5 meters of sea level rise, over 60% of our land area will be impacted. All right, so sea level rise is very, very serious for us in the Bahamas. All right, another projection that we'll look at is the increased intensity of extreme events. IPCC projects that there is a likely increase in tropical cyclone maximum wind speeds. And we talked about tropical cyclones, also known as hurricanes for us, last week. It's expected that hurricanes will increase in intensity. And you know that as you have like a category 3 as compared to a category 2, it causes much more damage. All right, greater intensity of hurricanes, if you combine that with higher sea levels, it's going to lead to higher storm surges. You know, the storm surge is the ocean waves that come in, and it's the most dangerous part of a hurricane. So you can imagine the impacts that will have. All right, Hurricane Joaquin was about a Category 3. When it hit most of our southern islands, you could imagine if it was a Category 4 or Category 5. All right, very devastating impacts. And imagine if we had a Category 5 hurricane that hit Nassau. Most places would be underwater. All right, associated with climate change, lots of other impacts within Bahamian society. So it will have an impact on tourism. If it's hotter here, if the sea levels rise, that means we have less beaches available. If there's less precipitation, there's more intense hurricanes. All of this is not very good for tourism. All right, so that will have an impact on the amount of tourists that we get coming here and on our #1 economic driver. All right, there are also expected to be negative impacts on health, most likely increases in vector-borne diseases. So these are diseases that you may get from mosquitoes and other things. Insurance prices are likely to go up because places will now be more vulnerable to things like flooding and hurricanes. And in some places, it could even lead to a loss of insurance coverage where places will no longer be able to obtain insurance. And there are also expected to be negative impacts on agriculture. All right, so as it gets hotter and there's less precipitation, this is not very good for any agriculture. All right, the cost of climate change. So all of these impacts are associated with the cost. And by 2050, it is expected that the annual cost of sea level rise alone will equal $3.9 billion. All right, and that is due to the loss of land, to the impacts on infrastructure and buildings that are already by the coast that will be impacted, and also from losses to different economic sectors. All right, the tourism sector alone is expected to lose about $900 million per year due to the loss of tourists not coming here and due to the impacts on infrastructure as well. All right, so overall, the Bahamas is extremely vulnerable to the impacts of climate change. So even though we do not contribute much to carbon dioxide emissions on a global scale, we are very, very vulnerable. We need to focus on adaptation. So we need to focus on reducing the impacts of climate change. All right, so taking into consideration what our environment will look like in the future and then developing in a way that accommodates for those changes. And we need much more focus on research, on public education, and involvement of the public in adaptation. All right, so most people are not even aware of how vulnerable that we are. And people need to know, perhaps not to buy places that are right along the coast and not to develop places that are right along the coast and to just to be aware of what's happening.